Hey everybody, in this video we are going to review logarithms without a calculator. And when the numbers get a little bit bigger on us, we'll use this table of exponents. So here in number 1, log base 3 of 1 over 27. So what that is asking is 3 to what power makes 1 over 27? Okay, now if we want, we can say that's equal to x and write it in exponent form. 3 to what power makes 1 over 27? Okay, so 3 to what power makes 27? When there's a fraction, I just kind of like to pretend for a moment that the fraction's not there. So 3 to what power makes 27? And if we're not sure, we can use the table here. This is 3 to the first power, 3 to the second power, and 3 to the third power. So 3 to the third power makes 27. But this is 1 over 27. So in order to take this number and put it into a fraction like that, I just need to make it a negative. So a negative power will do a reciprocal. So I use a negative third power to get 1 over 27. 5 to what power makes negative 125? And if I want to write it in exponent form, it looks like this. 5 to the x equals negative 125. There is no way to raise a positive number to a power and end up with a negative argument. So this has no real solution. And next I have log base 1/6 of 216. Okay, so let's pretend the fraction's not there. 6 to what power makes 216? So here I've got 6 to the first, 6 to the second, and 6 to the third power makes 216. So it's the third power, but I'm taking a fraction and turning it into a whole number, so I need a reciprocal, which means I need a negative power. Okay, now we'll solve some equations for x here. Okay, so if I want to cancel out this log base 9, what I could do is put a base 9 on both sides. So now it's 9 to the log base 9 of 2x minus 5 power equals 9 to the third power. And these cancel. So I have 2x minus 5 equals 9 to the third power. And 9 to the third power is 729. Okay, so now I can add 5. So I get 2x equals 734. Okay, now I need to divide 734 by 2. Okay, so 700 divided by 2 is 350. 34 divided by 2 is 17, so I've got 350 plus 17 is 367. Okay, next we have log 4x equals 2. Okay, so this log 4x, that's common log. There's no base there, which means it's a base 10. So just like I put a base 9 here on number 4, I will put a base 10 here on number 5. So I get 4x equals 10 to the second power, which is 100. And 100 divided by 4 is 25. Log 10 to the 17 power equals x. Okay, so this is log base 10 here. It's common log. So log base 10 of 10 to the 17. So what power raises 10 to make 10 to the 17? The 17 power does. Essentially, these cancel, and we get x is 17. Then we have log base x of 343 equals 3. Okay, so let's put this in exponent form. Base is x, exponent is 3, and the argument is 343. So x to the third power equals 343. So what to the third power makes 343? Now let's just use our chart. 343 is 7 to the third power. So I want to go to the third power column and find 343. That is 7 to the third power. So 7 to the third power equals 343. So that means x is 7. Next up, we are going to condense. When we condense, that means write these as a single logarithm. So in order to condense, the first thing I need to do is take this 3 here, this coefficient, and make it a power of the argument. So we've got log base 4 of 5 equals plus log base 4 of 2 to the 3rd power. Okay, so next, now that I've got 2 logarithms with the same base and coefficients of 1, I can condense into a single logarithm, log base 4, and I can multiply the arguments. The arguments are 5 and 2 to the 3rd power, which is 8. So I have log base 4 of 40. Okay, next I have 3 logarithms. The first thing to do is move all the coefficients back to powers. So I have log x to the 5th plus log y squared minus log z to the 7th power. Okay, now we can write them as a single logarithm. I've got all log base 10, so it's a single log base 10, common log, don't need to write the base there. Then I'll take these 2 that are added and multiply the arguments, x to the 5th, y squared, and this one is subtracted, so I will divide that argument, z to the 7th, in the denominator. Next, we are going to expand. So we have condensed logarithms, and we want to go the opposite direction. Okay, so I have log base 4 of k cubed, and then because these are multiplied, it's plus log base 4 of w, and because this is divided, it's minus log base 4 of b to the 5th. Now I have exponents that need to be moved into coefficients. So I have 3 log base 4 of k plus log base 4 of w minus 5 log base 4 of b. And number 11, I have log base 6 of 10x to the 3rd, so that's log base 6 of 10. And because these are multiplied, it's plus log base 6 of x to the 3rd, and I can move that 3 to a coefficient, log base 6 of 10 plus 3 log base 6 of x. Now I'm going to move to the end of this review where I've got 3 more problems that I intend to be done with no calculator. Okay, so I have log base 3 of 24, knowing that log base 3 of 4 is 1.26, log base 3 of 2 is 0.63, and log base 3 of 6 is 1.63. Now 24 is the same as 6 times 4, so this is log base 3 of 6 times 4. And I can expand that to log base 3 of 6 plus log base 3 of 4. Okay, because they're multiplied, I can add the 2 logarithms. So now it is expanded, and log base 3 of 6 is 1.63. Log base 3 of 4 is 1.26. So I just need to add those together. Okay, so let's do this vertically. 1.63 plus 1.26. 3 plus 6 is 9. 6 plus 2 is 8. And I've got my decimal there, and 1 plus 1 is 2. So I get 2.89. Next we have log base 3 of 6 squared, which is the same as 2 times log base 3 of 6. Okay, so I'm just taking this exponent and moving it to a coefficient. So 2 times log base 3 of 6 is 2 times 1.63. Okay, so 2 times 1.63, let's do this one vertically. So 1.63 times 2. 2 times 3 is 6. 2 times 6 is 12, so I'll carry the 1. And then 2 times 1 plus 1 is 3. So we have 3.26. And then we have log base 3 of 8 over 6. So that is log base 3 of 8 minus log base 3 of 6. So there it is, expanded. But I don't have an option with an 8. So I'm going to have to split that into 2 times 4. So that is log base 3 of 2 plus log base 3 of 4 minus log base 3 of 6. So we have 0.63 plus 1.26 minus 1.63. Okay, so 0.63 plus 1.26. So I've got 3 plus 6 is 9. And 6 plus 2 is 8. So that's 1.89 minus 1.63. Okay, 9 minus 3 is 6. 8 minus 6 is 2. 1 minus 1 is 0. So I have 0.26. Now it's important to remember that if I don't have the same number of places after the decimal, so let's say I was adding two numbers like 1.3 plus 1.63, I have to make sure that I line up the decimals. So I've got 0 plus 3, 3 plus 6, and 1 plus 1. Okay? So make sure you line up your decimals when you are adding or subtracting.